Okay. Hello everyone. Uh, Welcome to problem solving session for NPTEL course Introduction to Operating System. This is week 2 and we will be solving some quiz type questions related to week 2 content. I hope you had the time to go through the content of week 2, and like last time I will be giving you time to understand the question and then you all try to answer it. You can write your answers in chat box, and then I'll ask you to you can write your answers in chat box with explanation, and then I'll ask you to either explain it or give an explanation. So let's get started. Those who have any questions, please write them in chat box and I'll take it from there. Okay. Yeah. The previous recording video links are available on your course webpage, or I think it was posted. It's if you go to your course webpage, then in the end of the section. No, it's available there. If you go to your course webpage in the end of the course webpage, I think there is a section called problem solving sessions. If you go there, then you will have access to some Excel sheet, and YouTube links are available there. I mean, I think it is available. You check once. If it is not, then I will ask. I'll post it on Google discussion forum after this session. And I see some hands raised. So if you have any questions, then please write them in chat box, and I'll get started with the quiz questions now. Okay, first question here is there it's a match the following question. Sorry. You have to match uh, options A, B, C, D to 1, 2, 3, 4. Here, the first is present bit, and then dirty bit, swap out, swap in. All of these are related to page table and paging. So, uh, take a look and write your answers in the chat box. Okay, I'll post it on Google discussion forum, and I'll also get in touch with the team uh, and ask them to post the links. I'll post it after this session. For now, try to answer this question. answer says B. D, A2, B1, option B. Okay. Some of you are saying option B, some saying option D. Okay, so the right answer here is option number D. So present bit. Present bit is it is present in page table, and uh, it present bit means that whether it says whether it indicates whether the page is available in RAM or not. Okay, so it is option 4, match with option 4 here, page is present in RAM. Dirty bit. So this bit indicates that whether the content of the page were modified or not. If that means dirty bit, 0 or 1. 1 means that it was modified. Then swap in and swap out. So these are two processes, not processes, but two things which happen during paging when say no longer any free page is available. Then the OS needs to swap out the page from RAM so that it can bring in the new page. And so bringing in the new page which is required is called the swap in process. So bringing the page from disk to RAM is swap in, and then moving the page which is there in RAM to disk is swap out, and it is moved to the swap space, okay, on disk. So swap out is moving page from memory to disk, and swap in is moving page from disk to memory. So C is matched with 3 and D is matched with 2. So option 4 is here correct option. Do you have any questions?
Oh, ma'am, I have one question that if present bit is zero, then there is a page fault occurrence, and this is resolved through page fault resolution techniques, right?
Yeah. If present bit is 0, that means the page is not available in RAM. That then a fault occurs, general protection fault or the page fault, and at that time that is resolved by OS. Does that answer your question?
Yes, ma'am.
Okay. Any other questions? Okay. Let's look at next question. Uh, Here, consider a system. Second. Yeah. Consider a system using two-level paging, and the virtual address is 38 bits. The most significant 10 bits are used to index the page directory, and the next 16 bits index the page table. Each entry in both levels is 4 bytes. What is the maximum size of a page table in kilobytes?
Shall we solve it?
What?
Shall we solve it?
Yeah. Is the question clear?
Yes, ma'am.
Okay. Okay, I got one answer is 16. 16 is not right. Try again. You have to tell the size of page table in kilobytes. So here you have to write your answer in, if your answer, if the page table size is 10 kilobyte, then you have to write here 10. Any answers? Okay. 256, 216. Okay. Yeah, yes, Mohammed, you can write your question in chat box. Okay, just give me a minute. I'll set up whiteboard and then we can. Where's white? Okay. So those who have, okay, 256 right is right answer. Those who have given answer is 256, can you write an explanation for that? So can you mute yourself?
So, ma'am, answer is pretty simple.
Okay. Yeah, please go ahead. Yeah, someone was explaining, right?
Yes, ma'am.
Yeah.
So, in two-level paging, ma'am, can we look at the question once again?
Yeah.
So virtual address 38 bit is given. So 2 to the power 38 is the number of addresses, and it is divided into uh, each entry contains 4 words. So that is page table entry is 4 words, 4 bytes. Sorry, and we need to calculate page table size, and the page size is given. So if we can calculate number of pages on page table, then direct formula applicable on this. So
If we can find what? Number of pages in the page table.
Yes, number of pages in the page table.
And number of pages in the page table.
Yes, ma'am. Page table size divided by page size is number of pages in page table.
Yeah, but
Means that total number of page size.
no, but page table doesn't have pages. RAM is divided into pages or page frames. Your process address space is divided into page frames or blocks, and your page table contains page table entries.
So, 10 bits are used for six. 10 bits are used to index the page directory, and 16 bits to index the page table. So, page index directory is page table of page table, and the bits in page table index in page table is the page table, page of page table. That is page of page table.
It's not a page, it's a index in the page table. So it's a index to an entry in page table. It's not a page. When you say a page means a 4 kilobyte memory. The page term is used for a memory block of size 4 kilobyte. So it's not a page in page table. But I think you're just confused about the terminology. I mean, I think you're right. I think you got the concept and the answer, but you need to be a bit careful about the terms that you're using.
So,
Okay, so let me just write it. Where am I writing here? Why is it not visible? A second. I'm not able to write. I'm writing, but it's not visible. Anyways, let me set up Jamboard. Okay, it's visible. So your virtual address. Second, I have to. What's wrong now? Okay, I'll try to write this only. I don't know why it's not. I should have. Okay, I'll just try something. No, can't try. Okay, just.
And you can use paint.
No, I think I found the issue. The issue was that I was writing on two different whiteboards in two different. On my iPad, I was writing in different whiteboard, and here different. Sorry about that. Yeah, I think I found it. Okay. Okay, so this is your say. So this is your virtual address. Okay. Which the processor gave for translation. So processor is trying to address some memory in its address space. So the address which is generated is a virtual address, and in the question it says that the virtual address is of 38 bits, and it is divided into three parts. This 10 bits, then 16 bits, and then rest is 12 bits. It's 38 bits, so it's divided into three parts. The first 10 bits are used to index the page table directory. The next 16 bits are used to index the page table. That's right. Yeah. So the most significant 10 bits are used to index the page directory, 16 bits index the page table, and each entry in both levels is 4 bytes. So what does this mean is that your 10 bits here, they're going to index into a page directory. Now this is your page directory, and it has 0 to 2 to power 10 minus 1 entries. Okay, because there are 10 bits, so because of 10 bits there are 2 to power 10 entries in this. Each entry is of size 4 bytes. Okay, it's an entry of size 4 byte, and there are 2 to power 10 entries because 10 bits are there. Okay, and you almost know every bit can take two values, so therefore there are 2 to power 10 numbers which can be generated from 10 bits, right? That's why 2 to power 10 entries. Now if this is the entry, then this entry will be used to point this will be an index in the page table. Now which page table, right? No, this is the page table. Yeah, so this entry will tell you the page table. So there will be 2 to power 10 page tables. Every entry is an index. Every entry is pointing to a page table here. Okay, every entry is going to point to a page table. So this entry is here pointing to say a page table. Okay, this will be your page table, and then your 16 bit are used to index in this page table here. So since 16 bits are used, That means there are 0 to 2 to power 16 minus 1 entries in this page table, where every entry, which is called a page table entry, I'll write here PTE, which stands for page table entry. Every page table entry is of 4 bytes. Okay, so so one single page table here has 2 to power 16 entries, and each entry is of size 4 bytes. That is 2 to power 16 into 2 to power 2 bytes, which is 2 to power 18 bytes, or 256 kilobyte. That's so then your answer is 256. Okay, is it clear?
Yes, ma'am. Ma'am, we can also directly do this by just because there is, for example, in this page directory, there are segments of 2 to the power 10 minus 1. So, in this page table entry is 4 bytes, and the one page entry of this page directory contain 2 to the power 16 minus 1, 2 to the power 16 page table entries, and each page table entry is 4 bytes. So 4 into 2 to the power 16 is the page table size into 2 to the power 10 is the page table size divided by page table entry. It is 256.
I did not understand when you started including the directory part. So here I just explained this part. So this part was actually not necessary. This directory part, I didn't. I think if I had not talked about this, it was not necessary. I just explained all of this, the translation, complete translation, just for understanding purpose. But otherwise, just to calculate the size of page table, all you need is that how many bits are used to access the page table. If 16 bits are used here, that means there are 2 to power 16 entries in page table, and every entry is of 4 bytes. So 2 to power 16 into 4 bytes is your answer.
I just said that if a segment of this page directory contains the page table, is that right?
This so segment also, I think you shouldn't use the term segment here. Page directory also has entries.
Yeah, so page directory entries contain a page table. Each entry contains one page table
It
of 2 to the
contains
power
a
16.
pointer to a page table. It contains
Yeah.
the address of page table.
Yes, a frame number bits as well as the p bits, that is
Yeah.
processing bit, page bits, sorry, page offset. So
Yeah.
this page directory, which is pointing to the first page table, it contains a page table that is stored in frame number of 2 to the power 16 entries.
Can we take it after,
Yes,
later?
yes, okay, okay.
Yeah. Does anyone have any doubt in this? Does anyone have any doubt? Does anyone have any doubts?
Madam, please continue, madam.
Yeah. Can you please mute yourself?
Yeah, madam. Yeah, madam.
Okay. Okay. So question number 3. Consider a system using 2-level paging and virtual address is 38 bits. The most significant
Madam, at least this audio is a little bit, there is some signal issue with respect to audio. Will you just, fine tune it so that the audio can be much more be better?
Does others also have issue
It's
with
it's
audio?
bit reflecting, like it is something
No,
reflecting
it is
audio is
fine.
happening.
It is fine.
Sir, I think the issue is on your side. No one else pointed out issues with audio.
Yeah, ma'am.
Please check
There
it
is.
on your side.
Okay.
Yeah.
Okay. Yeah, ma'am. Yeah. Please continue, madam.
Okay. Thank you. Okay, question number 3. Consider a system using two-level paging and virtual address is 38 bits. The most significant 10 bits are used to index the page entry and next 16 bits index the page table. Each entry in both levels is 4 bytes. What is the maximum number of page tables that a process can have? So this is the same setting as previous question. Now you have to tell the number of page tables, maximum number of page tables. So I'll wait for your answers. Write them in the chat box. Any answers? Okay. There is one answer. Others? You can try even if answer is, don't worry about if the answer is right or wrong. Try it. Try the question. Okay. Uh, hmm. Okay. So let's see. So I got one answer as 1024. So 1024 is right answer. Question is asking the maximum number of page tables that this process can have. So if we go back and look here, so every entry in the page directory is pointing to one page table. And how many entries are there in the directory? The directory has 2 to power 10 entries. So that means 2 to power 10 page tables can be there. So and 2 to power 10 is 1024. Is that clear? Any doubts? Page table entry. Page table entry is 4 bytes. If you're writing page table entry, is that the number of page table entries you are asking? Number of page table entries will be 1024 into 2 to power 16. Yeah, that's right. Okay. Any doubts?
No.
Okay. I hope everyone is able to follow the questions and answers. Okay, next question. Consider a system with total memory available is 2 to power 38 bytes. Okay. So total memory is 2 to power 38 bytes. A user write a C program on this system that uses the entire addressing space. What is the size of a pointer in bytes defined in C program? So if your program, C program that you are writing, can access 2 to power 32 bytes of memory, then what will be the size of pointer in bytes? Okay, 2 to power n bytes used, n bytes for addressing whole chunk of memory available. And recheck your answer. And can you give the answer with n as 38? How many, what is the size of pointer in bytes? Okay, so I'll explain. And okay, this is your, so the question is saying that your C program can access this memory of size 2 to power 38 bytes. That means they so I'm writing the byte addresses are from 0 to 2 to power 38 minus 1. Okay, and now to access 2 to power 38 bytes, how many bits are required? How many bits will be required here? So 38 bits, right? 38 bits are required because to 38 bits are required because 38 bits can generate 2 to power 38 numbers.
Yes, ma'am.
So to access 2 to power 38 bytes, you need at least 38 bits. Now 38 bits divided by 8. Sorry about my writing. 38 bits. We have to convert it in bytes because the answer you have to give in bytes, divided by 8. Okay, so this will become your bytes. 4.7.
5 bytes.
Okay, now you cannot use 4.75 bytes, so so you have to use 5 bytes. So total 5 bytes, 40 bits will be required. 2 bits will be unused because you need only 38 bits to access 2 to power 38 byte locations.
And these 2 bytes can also be used by indexed allocation.
By?
Ma'am, for example, if we have a 20-bit CPU, then it generates 20-bit data, and we have a 7-bit, 20-bit, 9-bit registers for storing the data.
Okay.
So 20-bit is stored, not we will not be able to store 20 bits in 2 registers. So we need 3 registers. So that CPU memory utilization is less. So in order to tackle this, can we use indexed allocation method of memory management?
I am not sure what you're talking about.
Indexed allocation memory management, no internal, no external fragmentation.
Indexed allocation. How does indexed allocation come here? This we're talking about paging. How many bits are required to access memory?
This is a doubt that I had, just because in this we are encountering in internal fragmentation, just because these 2 bits are in use. So what if we use index allocation to just uh, get a reference of these bits, so that they can be used wherever we need just 2 bits more?
Okay, I'll have to see about that. I am not able to understand indexed allocation here. So maybe
Okay,
I
ma'am.
can look at it afterwards. Okay. Okay, then any other doubt? Okay, let's look at this question. This is the question is saying consider the following memory map using multi-program with partition model. Blue represent memory in use while white represent free memory as shown in the figure below. Request for memory follows the following order. So 100 kilobytes, then 25 kilobytes, 125 kilobytes, 50 kilobytes. Which of the following allocation satisfies the above request? Best fit, first fit, or worst fit? So these are the allocation strategies, and you have to tell which of these strategies will be able to satisfy these memory requests.
I'm done.
Okay. Okay. Any other answers? Okay. Okay. I think the answer is right, but let's see. Um, okay, so this is your memory map. Here blue regions are allocated and the only white regions are available. I have not colored them fully, but just these are blue, these are allocated. Okay, and the memory request is 100k, 25k, 125k, 50k. Now for best fit, what does best fit strategy says? So best fit strategy says that when a memory request is coming, then look through all of the free regions, free memory chunks which are there, and allocate the region which is just like the smallest region, which is equal to the size of requested block or greater than that, but the smallest one which is just equal or greater than the requested block. So that is the best fit. So according to best fit here, first request is 100 kilobytes. Okay, so 100 kilobytes, you will first check this. So this is greater than 100 kilobytes, so you can allocate here. Now so this is a possibility, so your possible answer is to store here. Can you mute yourself? Okay, this is possibility, but then you also have to look through all of the free chunks. Okay, you cannot stop here. So your possible answer here is 125. Then you look at the second one, 175. So 175 is also greater than 100 kilobytes, so you can allocate here also, but you have already, but the earlier option, which is 125 kilobyte, is a better option than 175 kilobytes, because that is uh, you can say that is smaller than 175 kilobytes. So we have to allocate the smallest whichever can fit the requested chunk. So in the best fit here, you are going to store this 100 kilobyte request here. Okay, which means that let's say this 100 kilobytes here is going to be allocated, and then the left part is 25 kilobytes. 25 kilobyte is left now. Now the second request is 25 kilobytes. Now you will again go through the memory map here, free memory blocks 25 and 175, and of course you are going to store it here. Okay, so this will be, because this perfectly fits, so this is taken now. After that, your next request here is of 125 kilobyte. Now you have only one free block, so you're just going to store it here, because it 125 kilobyte can be stored in 175 kilobyte space here, because that's greater. So you're going to take it and store it here, and then the left amount is 50 kilobytes, and the next request is also 50 kilobytes, so you're going to store it here. So this perfectly fits, and your request can be served this way in best fit allocation. Okay, next is your first fit. This is 125k and this is 175k. These are allocated. Okay, so next is let's look at first fit. 100k. First fit says that you are going to scan the memory. Okay, you're going to scan the memory from one end of the memory map. Okay, now here this map is given horizontal. It's actually not clear from which side to scan, but I'm just assuming that I'll scan from left hand side. It could have been made more clear, I think, in the question, or here I'm just it didn't change, it just, I think it's fine. So here I'm going to scan it from the left hand side, and the first block that you find, the first free chunk that you find, which can which is with whose size is greater than or equal to the requested chunk size, there you will store the chunk. Okay, so you just have to find the first available chunk which can be used to store it, whose size is greater. So 125 is definitely greater than 100 kilobytes, so you're going to store it here in 100 kilobytes. Left amount is 25. Okay, 25 kilo. Next request is 25 kilo, so which again you are going to scan from left side, and you find this chunk here, you find this block is free, so you're going to store it here. Now after that, the next request is 125 kilo, so you will store it here, and then the next is 50 kilo, so both of them together is 175, and of course they can be stored here. So in this manner you can, so the first fit also is able to serve all the memory requests. Now let's look at the worst fit. This was better. Okay, let's look at the for worst fit. This is 125 kilo, 175 kilo. And what is worst fit strategy? It says that scan all of the memory blocks which are free and store this block in the free chunk which fits worst, means which whose size is the biggest. Okay, store it in the biggest or the largest available chunk. So you're going to store it in the largest available chunk here, means here 175, and how many bytes will be left here? 75 bytes will be left. Sorry, 75 kilobytes. Next request is for 25 kilo. Now 25 kilo, again you are going to scan. So there are two free chunks, one of size 75, one is 125. Now which is the worst fit? The worst fit is 125, the largest is 125, so you are going to store it here. Now when you store it here, 100 will be left as free. Okay, so 100 is left as free here, 100k. Now next request is 125k. Now for this request 125k, two options are there, 100k and 75, and both of the chunks are smaller than 125k, so therefore this request cannot be served. So only best fit and worst fit strategies here can serve all of the memory requests. If you adopt worst fit here, then you will not be able to serve all of the requests. So hence the answer to the question is 1 and 2, option number B. Any questions?
Ma'am,
Yeah.
ma'am, when we are not able to fit the 120 50k or last process with the worst fit, then what does the last process do?
Then it won't be started.
That is, it just scans the whole wherever whenever it is free. For example, any process just terminates,
Yeah.
then it just continuously scan. That is what
No.
do we call it? Persistently scanning.
No. So whenever whenever a process finishes its execution, at that time its memory will be deallocated. When memory is deallocated, then first of all the merging will happen. So if there are two fragments continuously which both are free, then they will be merged together, right? You must have seen in fragmentation, right? When deallocation happens, then the fragments are merged together to create. After the merging process finishes, then the OS can look in the ready queue. So whenever a process starts, whenever a process becomes available for execution, it is either, if a processor is available, if resources are available, then it is in running state. If the processor is not available, if resources are not available, or some other IO is happening, then it is put in the ready queue. So in this case also, I think when a process terminates, then other process can be brought from the ready queue. And for that, scheduling algorithms will be there, like which process to execute next. And I think some
Yes, ma'am.
strategies
Yes, ma'am.
can be adopted here to better utilize the memory also.
Okay, ma'am. Thank you.
Okay. Okay. Uh, let's look at this question. This I will not answer. I'll just ask you to look at it, try to answer it. I mean, don't answer it in the chat box because this question is also there in your assignment. So the question is, you have to match this following. CR are control registers which are present in your processor. Okay, you can CR3 register is also called the page table base register, PTBR, and it was mentioned in the web page. I mean, it was mentioned in the course content. CR0 wasn't mentioned, I think, but you can just Google and find out. Kalloc and Kfree, these are kernel alloc, kernel free. These are functions in the kernel code. And alloc and free, I think all of you understand what does alloc and free methods do. These are
Yes,
similar to
ma'am.
malloc and free.
Yes, ma'am.
Okay, so this question I'm skipping, but the answer is also here. Yes, fine. True or false? Okay, have to. Anyways, the answer is there. So then, true or false question. During swap out of a page, all the changes that occurred in a page are updated in the memory. True or false? So, what does happen in a swap out?
And the process is either terminated or just preempted or gone into block state or gone into suspend ready
No,
queue.
but what is swap out? I'm not
Swap
asking
out
why
means
swap out.
like RAM, from RAM to main memory. From main memory to secondary backing store, secondary memory.
Yeah, so from main memory, you move the content to store disk.
Backing store.
Mm. Okay, then this statement is true or false. It is saying that during swap out of a page, all the changes that occurred in a page are updated in the main memory. It's true or false?
It is true, madam.
Okay, why is it true?
Because if the page is not used in the main memory, then that page, that page will, the page which is not being utilized in the main memory, obviously it will be updated. That page will be updated in the main memory because it has to indicate that there is an empty space in the main memory. That it has to indicate that there is a free space.
Okay, I think you don't. So that's. I think the answer is not correct. I mean, the explanation is not correct, and the answer is also not correct. So I'll just explain why. So, swap out. So, swap out means that the page is moved from main memory to the disk. Okay. uh, why When does swap out happen? Swap out happens when your physical memory, your RAM, doesn't have any free pages. So when it doesn't have any free page and your process requests a new page, it is requesting to access some page which is not present already in RAM. That means that new page needs to be moved from disk to RAM. But RAM doesn't have any free pages available. So you need to remove some page from RAM. So when you remove a page from RAM, then there are two options that you have. The first option is that there are two options based on whether the page is dirty or not. A dirty page means that the page was written, the content of the page was changed. Now, if the content of the page was changed and if you do not save it back on the disk or the storage device, then the content will be lost. Okay, then the process content will be lost, the data will be lost. So, and if the page is not dirty, then you do not need to store it back in the swap space or the disk. But if the page is dirty, then you need to write it back to the disk, and then you can move the new page in that page location. I'll just explain it here once again. Quickly think.
But ma'am, in question it is given that changes that occurred. That means that modified bit is always equal to 1.
Okay, so I'll explain why the answer is false. So it is saying that the all the changes that occurred in page are updated in the main memory, which is false. It is updated in the disk or the swap space and not in the main memory. The page is there in the main memory, and in swap out process in during swap out it is moved to disk, so it is updated in the disk and not in main memory. So that's why it is false. Okay.
Yes, ma'am, that's true. But during swap out of the process, all changes that occurred, this means this statement means that modified bit is equal to always 1, not 0 or 1.
Okay, I wasn't explaining. I was just explaining what happens in swap out. The
Yes.
explanation was not specific to this question. So here the question uh, is saying all the changes that occurred in a page are updated in the main memory. That statement is wrong. If
Yeah,
there
backing
were
strip.
changes, then they will be updated in the disk.
Yes, ma'am.
Okay. And the explanation is there in the slide, in the videos. It has been explained very well in videos, I think you, but I will just try to quickly explain here again. So this is your, what am I doing? 1 second.
Madam, actually, from the main memory only the changes are going to happen in the secondary disk, right, ma'am?
Yeah, the changes are there. The changes are, so changes are happening in the RAM.
In the
Whenever
RAM,
your
right?
process is executing, the
Okay,
the process is in RAM.
okay,
A process in execution, a program in execution means
okay,
that the program is stored in RAM.
okay,
So if your program updates its memory, it is updated in the RAM.
okay. The finally, subsequently from the RAM itself, the changes are going to happen in the secondary device.
Yeah,
Okay.
yeah. So
The
it,
final thing is the secondary device will have the final values. You mean to say?
yes.
Okay.
So if your RAM has, say, this page, okay,
Right.
this page has some data, maybe it can be anything, okay, but your name, etc. There can be some details in this page which have been modified while the process was executing. Okay, now when this page here, which can be, say, I am giving 100, is page number is 100, when this page has to be moved out or swapped out. Swap out means that it is moved from RAM to the disk. Okay, so there is, you have a disk here. Okay, so this page will be moved from here to the disk, and this page is moved in swap out from RAM to disk, and it is moved only when the page is dirty, the page has been modified. Because if the page has not been modified, then the page copy is already available in disk, and it's not useful to copy it back. No, but the question here, the answer is false, and answer is false because it is saying that the changes that occurred in page are updated in main memory. The changes that occurred in a page are updated in the disk, not main memory. Okay, during the swap out. So this question, sector 0 is of dash bytes which is loaded into the location dash. So this is, I think this is a very factual question, and you would know this if you have looked at the uh, PC booting lecture, boot up. So what is the answer to this question? Have you seen this lecture video, the last lecture in week 2?
Oh, no, ma'am, I have not seen it yet.
Okay, false, third. Yeah, third option is right. I think you just answered for that. Yeah. So if you look at the video, you will, I think you should just look at it, and the answer is right there in the slides. So it's like sector 0 is of 512 bytes, which is loaded into the location this, and the question is regarding the master MBR, master boot record. So the MBR is stored in disk in sector 0. It is of size 512 bytes. It's the uh, bootable code, and it is loaded in RAM in location 0x7C 00 by BIOS. Okay, so look at that lecture. This question is also from that lecture. The bootloader switches the OS to dash from dash, and yeah, option A is right. So bootloader switches the OS to protected mode, that is the when the OS is running in 32-bit mode, when it can use the entire memory, entire RAM region, entire memory, 4 kilobytes, sorry, 4 gigabytes. And in the real mode, it means that it is executing in backward compatible mode to 8088, and that time it can access only 1 megabyte of memory in RAM, the lower 1 megabyte. So bootloader switches the OS to protected mode from real mode. Again, this is you should look at the last lecture in week 2, and it's right there. Okay, so the last question in this quiz is, consider the following memory map using the partition model, with blue representing memory in use and white representing free memory. A new process P new is of size 10 kilobytes. In which partition is P new placed for? Best fit, first fit, worst fit? And your options are here.
I'm traversing from left to right or right to left?
Do from left to right.
C option. C.
Yeah. So C is correct. So best fit strategy. Okay. So best fit strategy. Uh, we already saw for one question regarding this, right? So your request chunk has size 10 kilobytes. So best fit means you will have to look at all of the free chunks, and you have to find the smallest chunk which is greater than whose size is greater than equal to 10k. So here the smallest with size greater than equal to 10k is the 11k chunk. So you can put your new process in this last chunk, 11k. So for best fit your answer is 11. For first fit you're going to scan from here. Now 8k is less than 10, so you cannot store it here. 12 is greater than 10, so you can store it here. So for first fit your answer is 12. And for worst fit you will look at all of the free chunks again, find the one which is the largest, and you are going to store your new process in the largest chunk. So the largest is 40k, so your answer here is 40, and that is option number C, 11, 12, 40. Okay. Now let's look at another set of problems. In which of the following cases would a page fault occur? When a requested address is not in RAM.
Can you just go with that previous question? Because the 48K was also there, no, ma'am?
No, 40 was there. The largest was 40.
Why we have considered 40? Like, why not 48?
Oh, okay. So the question is
Because,
saying that the blue memory is in use. So blue memory
okay,
is
right.
already occupied.
Okay, okay, ma'am. Yeah, ma'am. Yeah.
Okay.
So, yeah, thank you, ma'am. Thank you. Thank you for time.
Okay.
Yeah,
Any other question?
yeah.
No, ma'am.
Okay. Okay, let's look at this again. Okay, so in which of the following cases would a page fault occur? First, when a requested address is not in RAM, and second, when a write operation is issued on a read only page. Okay, any answers? Okay. Yeah, I think so. What is page fault? Page fault, what when does page fault happen? So when your process tries to access a page, tries to access some memory, okay, uh, and then sorry, when your process tries to access some memory and then uh, what happens when it tries to access a memory? It generates a virtual, your processor is executing the processor will then generate a virtual address. Now virtual address needs to be translated to physical address, so your main memory unit does the translation. To do the translation it looks at the page table, right, or look at the TLB. Now let's not talk about TLB because it wasn't discussed in the lecture also. So page table is checked. It in the page table it checks that this virtual address, uh, So like this virtual address is present in which physical page frame. Okay. Now for that, so for that, if your page table entry says that this page is not present in the RAM, which means that the present bit is set to 0. If the present bit is set to 0 means the page is not present in the RAM, that time a page fault occurs. So the page fault is who generates the page fault here? Your memory management unit, that is your hardware, is generating the page fault. Okay, it is it is giving this signal that okay, something is wrong. Okay, and then that signal is caught by the operating system. Then the operating system will look at the signal and it will try to find out the reason for it. Like the signal will be generated based on the signal code. It will know that this is the reason the process is like has been stopped. Like it will look at the reason and the reason will say okay, the page is not present. Now the OS will execute and it will try to find a free page and move the requested page from disk in the free uh, page frame. Okay, or the swap out process will happen, but whatever, it is going to take care of the page fault. It will handle the page fault. So the first one is definitely when a requested address is not in RAM, that time page fault occurs. The second is saying when a write operation is issued on a read only page. So here also, when your process is trying to access a memory, then virtual address is translated to physical address. For that, MMU does the translation. When the MMU also checks the page permissions. So if you are trying to write into a memory, this is like a store instruction. It's trying to write into some memory. At that time, the page protection bits are checked whether the page is writable or not. It's writable, readable or not. And if it is not writable, if the write bit is not set, then again a fault will occur, and that is also called a page fault. Now for that, a different signal is generated, and but the signal is again caught by the operating system. Okay, now since this signal says that the process is trying to access some memory, is trying to write to some memory which is read only, in this case OS will terminate the process, because the process is trying to do something which it is not allowed to do. Okay, based on signal, the OS will uh, handle like the cases. Okay, but both of them are called page faults. So the answer to this question is 1 and 2 only, I mean both. So is that clear? Any question?
Hello, ma'am. You
Yeah.
just told us regarding this availability of the page in the main memory, right? When a requested address is not in RAM, when a write operation is performed, and we are not able to see the question, ma'am. Can you just go through the question? When a requested address is not in RAM, when a write operation is issued onto a read-only page, you are saying that 1 and 2, both in which of the following page fault can occur? Both the conditions is true, ma'am.
Yeah.
When a requested address is not in RAM and when a write operation is issued on a read-only page. Okay, right, ma'am. Yeah,
Okay.
it's true, ma'am. It's true.
Okay.
Because the read-only page, it is indicated, no, madam, by the bit like
Yeah.
the no, that it is indicated like it is a read-only page.
Yeah.
Okay. So we can also change it into a write operation also. Okay.
The OS sets
Yeah.
the permission.
Yeah. So that the page fault can occur. Yeah. Okay. Yes, ma'am. True. Thank you, ma'am. Thank you. Yeah.
Okay.
Yeah,
Any
ma'am.
other questions? Okay, if not, then let's try second. It's same as the last question we did. So here again the memory map is given. Your new process is of size 10K, and the new process is placed in which chunks here? P1 to P9 are the options: best fit, first fit, and worst fit.
Again, traversing from left to right as well.
Yeah. I think the question is same. No, it's a little different, but yeah. Answers P5, P3, P7. Yeah, that is right. So best fit 10k. 10 can, it's the best, right? You can get. Then the first fit is you're going to scan from left to right. 8k is less than 10, so you cannot store here. 20k is greater than 10, so you can store here. So P3. Worst fit, you're going to find the largest available, largest free chunk. So among all of this, 34k is the largest. So P7. So P5, P3, and P7 are the answers. Option D. Now let's look at next question. This I'm just skipping again, because it's there in assignment. The code from MBR is copied to RAM at location 0xCC0 by BIOS. So we already looked in the last quiz, and it's factual. So I'll just say that it's, but still you can try. I mean, answers. Write your answers in the chat box. Yeah, this session is recorded, and I'll put it on YouTube, and I'll share the links. I'll post the links of both the first and second videos on Google discussion forum. So answers, yeah. So I got one answer. It is false. Why is it false? Right. So it is false. Okay, I got two answers. It is false because the location is 0xC00. Okay, it's 7, sorry, 0x7C00. Everything else is right in this line except the location. Okay, now Dash performs the power on self test. Which of these components perform the power on self test? So the answer here, any answers? Okay, they got answers as BIOS. Right, so BIOS performs the power and self test. This is false. Okay, next question 6. So there is nothing to explain here actually, so I'm not explaining uh, anything. Consider a system where total memory available is 2 to power 64 bytes. Okay, a user writes a C program on the system that uses the entire address space. The size of a pointer defined in this C program should be dash bytes. So we did this similar question in last quiz. Uh, so I think you can answer this question.
There can be two options. One is 16 bytes or it can be 8 bytes.
Okay, how can it be
16
16
bytes.
bytes?
Size of the pointer. You are talking about the memory space of the pointer, madam. Right, no, madam?
The
The
size,
size of the pointer.
yeah, the size of the pointer.
Size of the pointer defined in the C program. So pointer space. You are talking about pointer space in the C program. So it is you are talking about C program pointer space.
Yeah, what
The
is the
size of the
size
pointer.
of
You are
pointer?
talking about C program pointer space, right?
Yeah, I mean size of pointer in C. So,
C program, right?
yeah.
Basically, you are going for C program. C program's pointer space.
Pointer, what is the size of pointer? That's the question. Not space. What is the size of pointer?
Pointer.
Hmm. In bytes. Any answers?
It
8
depends upon
bytes.
the machine, madam. Normally, it can go for 64 bit also, as indicated in that available space. But normally, when we look at integer, it can be of 16 something like that. But it can go up to 64 bytes.
No, but the question, you have already been given the size of memory. So
Size
that
of
is
memory.
based on the size of memory.
So it can be of 64 bytes, madam. It depends upon the computer also.
Okay.
For 4,
64.
it can go from 4 bytes to 64 bits. So as it we are talking about technology, it can be of 64 bytes. 64
You
bits.
No,
64.
the question is asking, so you have to answer according to the question, not what is the state of the art. Not,
Normally it will be 8 bits. 8. It will be of 8 bytes, madam.
so you do not answer the question according to what is normally happening in C program on your machine. I'm
Okay.
saying that when you are asked a question in a like a exam or something, then you answer it according to the specification given in the question. So the question if says that the memory available is 2 to power 10 bytes, then you have to answer according to 2 to power 10 bytes of memory.
Okay.
Okay. If a question here is saying 2 to power 32 according to that. Here the question is saying the memory available is 2 to power 64 bytes. So
Okay.
how many, what
Size of the
bytes
point
are
defined in the
required?
C program should be of dash bytes.
I mean it's not your laptop. You don't have to answer it according to the what is the current technology. It's just like, as question is saying that your memory map, your process memory map is of size 2 to power 64 bytes. That means there are 2 to power 64 addresses. Now one single address will have 64 bits because there are 2 to power 64 addresses. So
Okay.
one address or one pointer is of size 64 bits,
Okay.
and 64 bits is 8 bytes.
8 bytes. So normally it will be of 8 bytes only. 8 bytes. Yeah.
Okay, again I'll say that don't answer the question here based on normally what is the size in your C program. If you go and you can just say create an integer pointer and then you're going size of pointer, that's not how you have to answer. You should answer the question based on the question statement. Okay.
2 raised to 64, how it came 64 by 8 bytes, madam? Like, I'm not able to get it, like 8 bytes.
2 to power, so it's, I think it's explained here, right? Same. Your memory map is of size 2 to power 64 bytes.
Okay.
Means
Yeah.
your there are 0 to 2 to power 64 minus 1 bytes. I mean you have 2 to power 64 bytes, and addresses are from 0 to 2 to power 64 minus 1.
Okay.
And your addresses, now to address any byte here you need 64 bits.
Okay.
64 bits is 8 bytes. 64 divided by 8 is 8. So 8 bytes.
64 divided by Okay. Okay.
Yeah.
Right. So 2 raised to 64 addresses some 2 raised to 64 minus 1. It's 64 bits. 8 bytes.
So here 2 to power 64 minus 1. So your pointer here will be of 64 bits.
Okay. Okay.
Okay, and 64 bytes is 64 bits is 8 bytes.
Okay. Guess 64 bytes. Okay. Then
Okay, so here the answer is 8. Now,
but there is no, like, it is not given as 64 bit, no, madam. Each memory location addressing like 864. Each memory is of 64 bits.
your memory size is given.
Okay.
Your memory has 2 to power 64 bytes.
Okay.
So I'll just, okay, just like simply,
Ma'am,
if you're,
in this can be interpreted like this, that 2 to power 64 bytes, that is 2 to power 64 is the blocks, and the 8 bits is the size of a block. So 2 to power 64 is the binary bits, 8 bits, 64 bits are used to address that 2 to power 64 blocks, and then we can say that.
one second, I'll just explain it like very simply. So let's say that your memory is of size 4 bytes. Okay, your RAM is 4 bytes only. Okay, that means there are 4 bytes here. I'll explain it for 4 bytes, and you just try to answer it yourself for 64. Like 20, your RAM is of size 2 to power 2 bytes. Okay, so your RAM has 4 bytes, and the byte addresses are, these are your addresses, byte addresses: 0, 1, 2, sorry, 2 and 3. Now, how many bits are required to address a byte?
Log to the base 2.
So you can here use log also, but so you need only 2 bits, right? When you say 0 0, this is your address. If you say, I mean, this is 0 0 0 1 1 0 1 1, so you need only 2 bits to address 4 bytes. Yeah, use the log. So if your size is 2 to power 64, then you need 64 bits. If your RAM size is, I mean, if I do it progressively, if your RAM size is 2 to power 3 bytes, then you need 3 bits, because 3 bits possibilities are 0 0 0 0 0 1 0 1 0 0 1 1, then 1 0 0 1 0 1 1
110.
okay, and they will be mapped to this 8. There are 8 bytes here. These are the bytes. This is your RAM now, 8 byte RAM, and these are the addresses, and the addresses are of 3 bits here. Okay, so when your RAM is of size 64, sorry, RAM is of size 2 to power 64, here then it has 2 to power 64 byte addresses, and you need 64 bits to address a byte in RAM.
Yes, ma'am.
Okay. Okay. Okay, next question is the space in hard disk used to store inactive pages of a process is called temp folder, users, home directory, swap space, none of the above. Yeah. So Raghav says swap space. That's right. Does anyone have any question or doesn't agree with the answer?
I mean, like it's just a terminology, right?
Yeah, it's just a term. Yeah. Okay. The boot, because it's also even just asking you it is called, right?
Yes, yes.
Okay, eighth is the bootloader is an x86 system. The bootloader in an x86 system switches the OS2 from, which we already answered, is it switches to protected
Okay.
mode from real mode. Okay, so the last one,
Same.
we've already done it, or I think I
Yes.
have skipped it.
No, ma'am. Done, done.
Okay, so it's repeating question. Okay, so these were the questions that I had for today. Now you can ask your questions if you had any doubt anywhere, and then we can discuss that now.
Can you recollect that match the following one? Match
Oh,
the following.
this last one?
Yeah, match the following. Last one, yeah.
I mean, I can do it, but I am just
Present bit,
1 second.
30 bit. You talked about that, right? 30 bits and all those
Can
things.
anyone just tell me that this question is in your week 2 assignment or not?
Just a minute. I will check.
30 bit swap out, swap in. Page in RAM. Page in RAM. When can the page be in RAM? There can be moving a
No,
page.
ma'am. It is not.
Okay,
It is not.
okay.
RAM,
Yeah,
moving a page from RAM to disk is page from RAM to disk. You are moving from RAM to disk. So RAM to disk is obviously swap out. 3C.
RAM to disk is,
RAM
yeah,
to disk.
swap out.
Swap out. So 3C.
Yeah,
3C.
yeah.
3C. 3C means obviously 1.
3C means obviously 3.
3C,
Obviously 3.
3B,
Third option.
3C. 3C. Third 3C. Third option.
Yeah.
3C. So A4 you are going to say, right, ma'am? Present bit is page in
RAM.
present in the RAM.
Yeah.
Yes.
Dirty
Right.
bit means that the difference in content
Different
of page in
contents
RAM
of
and disk.
RAM and disk. 30 bit. Okay.
Swap in means the page is moved from disk to RAM.
Okay. Moving a disk or swap in moving a page from RAM to disk.
Swap in from disk to RAM. You are bringing from disk to RAM. So when your process executes, the process should be in RAM. So when we say in means we are bringing it in from storage to memory. Okay, storage is your disk, memory is your RAM. So
Okay.
swapping in means bringing the pages from disk to RAM. And
Okay,
swap,
ma'am. There is one more match the following. You just can you recollect me that one? There is at the top.
this
C
I
zero.
this is actually part of your week 2 assignment this time also. So
Okay.
that's why I'm not answering it now. I'll discuss it after the
But
break.
you just talked about that K alloc and CR3.
Yeah, I was saying that CR3 is the page table base register.
Okay, that
It's
means B. 3B is the right answer, right? Page table register. 3B.
3B.
3B is
Yeah,
there, mean.
yeah,
3B means obviously second and third are the two options.
yeah.
And K alloc, what do you mean by K alloc? K alloc you
Uh,
were discussing.
Yeah, so it's like alloc is, so you have malloc, right, in
Lock,
C.
yeah, yeah.
So that is memory allocation.
Okay.
That is used to allocate memory
Add
dynamically.
the free pages to the list, obviously.
uh, kalloc is also similar to allocation, but
Okay.
it's a kernel function, it's
Two
in the
C,
kernel
two
code.
C, two C, two C. They are not mentioned, no, madam. Two, two A is given, and I mean two. What is this? Two A and four A.
C is,
What is this one? Four A enable page. C3 you said about page table. So 3B there are two options, ma'am. One is 2A, 2 and 4A. 2A,
this
2
you
is 4.
uh, try in your assignment.
Yeah.
I mean, I
K
think.
free is obviously remove the pages from the memory, ma'am. That can be done. So, but that also is not there. Three, four, no, 4A, 4A. Obviously, third is the answer. 4A, 4A, 3B, C1, 3, C1, obviously C1. Remove the pages. Yeah. No, C1 cannot be right, no, ma'am. C1 cannot be there. Remove the pages. Huh? Okay, remove the pages from the list.
Yeah, I mean, yeah, I'll explain it
Yeah.
next time. You
Yeah.
just
T2.
think, or you can just Google also, or think about it.
Yeah.
It,
C3 is enable page table register. Page table register, that is the right answer. 3B, 3B. Okay. D2, 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 add the pages. D2, D4, D4, D4 cannot be. D4. I think second is the right answer, madam. I think so. A2, CB, 3B, C1, D2, D4. D, not D4, C2, D2.
okay,
A4, A4, B3, C1, D2. Third was the right answer. Third option is the right answer.
okay,
Probably.
I'll tell
Yes.
next time.
Yeah, ma'am. Yeah.
Okay,
Okay.
and I mean, the solution will be provided anyway for the assignment. Okay,
Okay.
okay, so any other doubts?
Ma'am, actually, the week one you have discussed, ma'am. Week one
Yeah,
assignments.
yeah, not assignment, I mean, not this.
The the quiz.
Yeah, so the quiz deadline is 9th of August, right? So I
I think
haven't discussed the this time's quiz. I have discussed some similar like questions for week 1, but not the current quiz which is given to you.
yeah, yeah. Okay.
For that,
I
the
have a
solution
question.
will be made available to you, but I will not be discussing that in this lecture, because then every week I am every week I am going to discuss question related to that week's content. So next
Ma'am,
week.
to be honest with you, I don't want to, deviate the things. See, what we expect from the presentation, the lecture notes, clearly I'll tell you, is that we need proper notes, what is being discussed in the, in the videos. We please kindly make some bit effort, like, please kindly make an effort so that whatever you're presenting in the video has to come over there in the, the PPTs, which normally there is a lot of deviations going on. We are not able to find certain question solutions and all those things. So which I observed in most of the videos. I mean the PPTs are not that convincing most of the times. Please,
it's
I
a
request you.
it's a problem solving session. I'm not giving a lecture here, so I am just solving
I'm not
problems.
talking about the the problem solving. I'm talking about problem solving only. Please kindly request to the persons who are giving the videos over their sessions.
Which
See that
sessions?
the quizzes are not relevant over there. Because most of the quizzes we are not able to solve
No, no,
properly.
which I am not getting the context.
Ma'am, the quizzes are given, right, ma'am? Quiz one, quiz two,
Yeah.
every week, right? So those quizzes and the PPTs, whatever they've been, the lecture notes that are being given there, lecture notes, they are not, quite synchronizing. They are not
Okay.
quite
So
synchronizing.
you're saying that the questions are not from the PPT.
I am not going to say exactly. I don't want to be exact. I don't want to be exactness, but to a certain extent, we need some things which need to be so that we can learn ahead. Quite relevant. I'm not
Ah,
talking about exactness.
so
I'm not talking about exactness. We need examples. We need examples like the one you explained here. I mean, for example, you talked about the pages, how the dirty pages are there for with the relevant examples, and how with respect to the address and all
yeah,
those
so
things you have
that's
explained. That has to be given, madam.
l-
Quite to a
so
certain extent.
the lectures have already been recorded by Professor Chester and they cannot be modified now.
I'm not talking about the lecturers. I'm not talking about the
So
lectures.
I'm
I'm
not
talking about
I'm
the presentation PPTs, the notes which have been, which we are going to download, the lecture notes. So
but
they need to be refined. They need to be fine tuned. So
the
according to
lecture
the requirement
notes,
of
can
the
you
people.
let me speak, or I'm not, otherwise I won't be able to even.
Ma'am, we are hearing you. Yeah.
Yeah, so I'm saying the lecture notes which are being made available to you, they are lecture notes which are discussed in videos, right? Now,
Yeah, that
if you are
they are
saying
there.
that the lecture notes need to be refined, that means the videos need to be
I'm
refined.
not talking about the videos. I'm not talking about the videos. I'm
I'm not
talking about
in
the
the.
PPTs, the PPTs, the PDFs, the PDFs,
But
the
how do you
PDFs.
want them to be refined?
I know we can refine them according to our requirement. Suppose it is 1 week's time is given, right?
Yeah.
Every week you are uploading the the notes, right? Kindly go through that notes, whatever they are. You can go through the notes, right?
But
You can go through the notes, each notes, what are given
what do
there.
you want to get refined in those? That's the question. What
Like
refinement
for
do you want?
example, one example you are giving them, you are explaining one example. That
Okay.
example, whatever the example you have explained here, that relevant example has to be discussed.
But these sessions have to be taken together, right? You can come and join the problem solving session, and that's the goal here to help you solve
And
some
most of
question.
the times I tried to log in also. I joined around 3:30, for example. I'm sorry. I joined around 3:30 and I was trying to log in, and after some times I was logged in, and this
But
happened.
okay,
So
but then the recording is also available, so you can look at the recording also.
maybe in the YouTube it is available, right,
Yeah,
ma'am?
yeah. So that will be made available.
Yeah.
But the lecture videos or the video notes, everything has been done already, and I think we cannot refine it in this offering. I will give the feedback to Professor Chester, and he can decide about that, I think.
Okay. So that's the thing. I hope I discussed about that. So what I would suggest is, please kindly see that quite the whatever the notes are there that are similar to what been discussed in the class, the PDFs. Make sure that
Uh,
the similar kind of examples are given, like whatever that are discussed, like at least it's not exact, a similar type of examples
so first,
in the
I'll
PDFs.
just stop the recording.
Yeah.